Hello everyone, it's Steve with Aptera Owners Club. So today, Aptera put out their June 2024 update, and Steve Fambro is the spokesperson this month, which I think is great. Chris obviously does a great job, but Steve kind of gives a more technical feel, and I kind of enjoy that too. So let's watch this together, and I'll give you my comments on it.
Hi, Aptera fans. Steve here. We've been thrilled with the progress the team has made in the past month. Let's talk about some of the big milestones we're making on our production intent vehicles, which are the vehicles used for validation and testing of the production design. Earlier this month, we shared the latest on our battery module validation. Tim Vaughn reported that our modules passed accelerated life cycle testing on the shock table at a local laboratory. And since then, we've assembled the rest of the modules and completed laser welding.
So here we go. A lot of people complained, oh, Aptera is not building their modules. They made this one module for testing, and they don't even have modules built for the PI vehicles. Well, here you are. We can clearly see at least 5 of them. And you can see that the tabs are welded down, and these look like they're ready to go. So I think there's some footage in here that will put to rest some of the things that the naysayers have been saying about Aptera.
For PI2. Let's quickly cover the differences between PI1 and PI2. PI1 is our wire harness test mule used.
Okay, so here's the wire harness test mule. Remember, they got this about a month ago, and there have been complaints like, oh, there's been not a single picture about with the wiring harnesses or the wiring in the vehicle. It's just been sitting around. They haven't been doing anything. Well, we're about to see a lot of pictures of wires in the wiring harness mule. And so they have definitely been working on it. You can see here the air handlers in here and some other things
for fitment validation and cable measurements, while PI2 will be the first of a series of driving vehicles. Now, most of the progress that you'll see today will be for PI2.
Okay, so we know now the PI2 should be a drivable vehicle. Now, I suspect PI2 is going to be kind of like beta, an ugly drivable vehicle. I don't think it's going to look pretty and have all the things. It's probably just going to be fairly bare bones looking, is my guess. But I guess that remains to be seen. But I'm pretty sure that that's what it's going to be.
Which we're excited to begin testing in real-world locations soon. Let's check out some of the work that PI1 has allowed our team to accomplish. Running cables in this bink has allowed us to adjust the.
So you can see here that
has allowed our team to accomplish.
They're putting the things in
running
with like
cables
tape
in this
right here. They're just putting in with tape. So it's unclear as you watch these things how these little circuit boards are going to be secured in the vehicle. Actually, so a lot of the little fittings have been molded into the bink, but it's pretty clear that the fittings for the circuit boards have not been molded into the bink. I suspect that the exact configuration and the size and stuff of the various electronic pieces had not been finalized at the time when they made the bink, and it's probably not super important that these be secured very, very well. They're very light, and I'm sure that there's many ways of securing it. I mean, I think you could just like hot glue it or something in there, or something like hot glue. I mean, I'm not an automotive engineer, but like it doesn't require a lot. It's not very heavy. It's not going to require a lot. So currently they're just taping it in there. Obviously, this is not what the production vehicle is going to have, but I don't see any like places where this thing screws in. So I think it's going to either have to be glued or somehow fastened in there in a different way. But you can see they're clearly doing what they said that they're going to do. They're making sure the wires fit and the various pieces fit, and they're putting them out, and they're just testing them out to make sure that it works like they thought it was going to work.
This bink has allowed us to adjust the cable links in the real world and be sure that cables are routed how we expect them to be. Each sticker that you see in the bink represents a device in the vehicle as the team takes components in and out, complementing fitment checks. Inside PI1, we have our air handler along with the custom air handler control board. Also inside is our B-pillar control board, and it will control and monitor things such as a door latch.
So yeah, again, you can see like these things. I think this must be the logo here. But these things, I mean, I'm sure that's been thought of in a way to secure that. But like this thing, see, there's not like a little screw thing that you can screw into. So they're going to have to fasten this another way. My guess is it's going to be glued in. And that would make the most sense. Then you wouldn't have any vibration. It wouldn't come loose. That's probably the best way to do it. And then if you need to replace it, there's probably just put like a heat gun or something to undo the glue and then just replace that part.
The door actuators, and the knock-knock sensor. These two boards are some of the distributed circuit boards around the vehicle that control co-located devices. We do this to cut down on wire harness weight. We also cut down on the connector sizes of these boards and try to use more direct wire-to-board connections to save even more space and weight. Many of the boards also don't have traditional bulky enclosures, and they instead are going to be made with dust and waterproof coatings. Now, this is a kind of approach we take around every engineering decision.
But yeah, I really like that. I mean, these boards are inside the vehicle. They don't need to be that protected from the environment because they're already protected from the environment. So they're not going to add another enclosure on it. That's just extra work, extra cost, extra space, extra steps in manufacturing. So they're just going to like spray something on there, I guess, to protect it a little bit more before they install it.
And to make sure that every journey can be powered by the sun. Next, let's talk about PI2. Last month, our chassis and suspension design got finalized thanks to our Italian team. This month, I'm thrilled to share that the chassis and suspension are being made right now and will be at Aptera headquarters this summer.
Okay, so that's a little vague. I don't know what the lead time is, so I'm guessing they don't know what the lead time is either. I mean, summer could be as late as end of August. I think like end of summer in America is thought to be like Labor Day, so which is like early September. So they're saying by this summer, it could be July, could be August, could be early September even. So we know that PI2, if it's going to be a drivable vehicle, cannot be built until this chassis arrives. And if this chassis arrives in early September, you know, we're not going to see a PI build until like mid to late September. And so I think in my mind, there's already some timeline slippage happening. And so I think the timeline where there is a delivery of an Aptera like customer vehicle in early 2025 is not likely, given that I don't think we're going to see a drivable PI build until maybe September. Because I think if it was going to happen in July, my guess is they would say, oh, it's coming in July, because for it to come in July, they would have to be almost done with this and getting ready to like package it and ship it over here, because July is just like next week. And so I think they're thinking more August, maybe September even for this.
The order is made up of multiple metal pieces, with some being CNC'd and other smaller parts being bent out of aluminum. We've already seen progress from the factory and are thrilled that these parts will be ready soon. In preparation for this exciting time, the electrical systems team is continuing low voltage and high voltage integration testing for the components used in PI2.
Okay, this looks really cool. Like this is also footage we've never seen before. This is some kind of mock-up of the electrical system in the Aptera. I think this is one step away from what they need to do. They need to have a full mock-up of this in the actual vehicle. So they did the wiring thing with PI1, and then they need to redo it, maybe in PI2, or maybe they'll do it in PI1. But they need to reconfigure this test bench on a vehicle, I think. And I'll show you why I think that.
Outside the vehicle. Now, this bench validation is a critical step to ensure that engineers have full access to the devices.
So yeah, this is cool. You can see, like, I don't know what an OBC-AC input is. And it's AC compressor, DC to DC, inverter, solar, battery heater, cabin heater, charge port. So this is cool, but it's all box. So it's a very this is just a test bed. They need to put this into a vehicle and test the electrical system in the vehicle. And what made me think of that is there was this cool video about that CNET did about Rivian, and you can see that there's this test mock-up of the Rivian.
Transformers lab, what is this? So this is what we call a lab car. This is where we put together all the electronics that belongs in the vehicle together without the actual body.
And you can see how complex the electrical system in a Rivian is. It looks like it's much more complex than the Aptera, which is good in terms of cost and manufacturability for the Aptera.
And this is how we get to test to see that it actually works. This gives you a sense of just the amount of electronics that exists in the modern vehicle. Everybody talks about it, but gives you a way to actually literally see it. There's a high performance imaging radar. Down here, high compute systems.
So you guys see how this is basically a mock-up within the actual vehicle, like the frame and the chassis of the vehicle. So, and with all the parts in place. This is just a box. And so this recapitulates a much better test bed to test and validate things. So they need to do this, I suspect. I don't know if it's going to happen with PI1 or PI2 or PI3, like one of these, but they need to do this. And recently, Rivian just got a big cash infusion from Volkswagen. Volkswagen is giving them $1 billion. And remember, Rivian is in this area where they have a successful vehicle. People are buying the vehicle. They're manufacturing the vehicle. And people are generally pleased with the quality of the vehicle. But they still are burning through cash, and they need to stop burning cash. So they're running out of money, and so this helps them. They're getting a $1 billion cash infusion that keeps them solvent for a while longer. And if this goes through, then Rivian is going to get $4 more billion from Volkswagen, and Volkswagen is going to give them a total of $5 billion if everything works out according to plan. And so what Volkswagen gets out of this is Volkswagen is getting access to Rivian's hardware and software stack, because they're trying to move, the auto industry is trying to move to something called a software defined vehicle. And this is an article I found from TechCrunch on what the F is a software defined vehicle. Basically, it's not exactly clear, but basically what they're saying is they're trying to make cars so that they can be upgraded by software. So the way that cars have been made is they build hardware that does a certain thing. There's an ECU for each part, and then they build it. It all works together. They test it. It works like it's supposed to, and then they release the vehicle, and that's the vehicle they sell for 5 years until they redo it and make the next model. So there's not that much software in a car. It's like what little software in there is set, and the small updates they do don't noticeably change the behavior or the capabilities of the car. But what they want is they want a car that basically has processors that can do multiple things, and you can change the behavior of the car and the capabilities of the car through software. And that is what Tesla is doing and what Rivian's doing, and that's what they realize that the other companies are going to have to do, because that's what we're moving towards. But it's very complex, and VW doesn't want to develop it again, and Rivian is going to share that with them in exchange for some cash infusion and some investment in the company. So I believe Aptera is doing a similar thing. They have a different architecture, but I think Aptera is following in the footsteps of Tesla a lot. And so a lot of their capabilities are going to be software defined. And I believe that they're doing a similar thing. And I think that's good. I think some people have some concerns about their vehicle being able to be like changed via software. But I think that is just the nature of how technology is moving towards. It gives you a car that you can fix over the air, any problems, and you can update it, you can give it new capabilities, and you can, quote, improve the vehicle. Now, what a lot of traditional automakers are thinking is that by making it a software-defined vehicle, they're going to give you capabilities, but then make you pay for those capabilities. Like they'll make it a subscription service. Mercedes is doing that a little bit, like to access the full capabilities of the car, you have to like buy a subscription, which I think is really lame. So I'm really not in favor of that personally, but that they see that as a revenue stream. Like, you remember how airlines used to like give you food and give you drinks, and you could take your luggage and stuff, but then they kind of like nickel and dime you for every little thing now, which I know we've kind of gotten used to, but it is a little bit annoying. And I think by making it a software defined vehicle, you can control a lot of things in software, and you can turn it into a revenue stream for them. Now, Aptera has not said that they're doing that, and I don't think that they're doing that, and I hope they don't do that. I think that would be pretty lame. But they are, I get the impression from talking to them that they are trying to make a vehicle that you can update over the air pretty easily, and that you can like update the software and update the capabilities of the car. So I think that part is great.
This is in a controlled, safe environment. Solar is making great progress.
Okay, so I think this video has gone on long enough. Let's cover the next part of the update in the next video. All right, thanks for watching, guys. Have a great day.